Hey everybody, this is Mr. Beckstrom. I want to do another example from section 7.3. Here it says, use a graphing utility to solve the equation. Express the solution rounded to 2 decimal places. And we have a function here, and this is an ugly one. It says 21x minus 19 times the sine of x is equal to 5. So normally solving this would be extremely difficult because solving for x would be hard. If we tried to do that, we'd probably have to get sine of x by itself on one side and then do the inverse sine. And it would just be it'd be a mess trying to solve that, and we'd only be able to do that in the domain of the inverse sine as well. So a way that we can do that with our graphing utility is like this. It's a little counterintuitive as well, but it works. And that is, make sure that you are in radians. So if you're not in radians, make sure that you're in radians. And what we're going to do is you're going to go to y equals. Now here we already have our x terms on one side and our constants on the other. If we didn't, then we would want to add and subtract from both sides until we did. So you want to make sure your terms with x's are on one side of the equation and your constants, those are terms without x's, are by themselves on the other side. Once you do that, then we're going to, in y1, we're going to put one side of the equation on there here. So I'm going to put 21x minus 19 times the sine of x. 19 times the sine of x. Just like this. Just one side of that equation. On the other side, I'm just going to put the constant there, 5. And so I have two equations here. And what I can do in order to find where these two things are equal is I can find the intersection of these two graphs here. And that's what I'm going to do. And however many intersections they have is how many times how many points they have in common. All right, so let's go ahead and see if I can find this. So let's go to zoom. Let's start with the standard zoom here and see what that looks like. And it looks like right here they only cross once, but let's go ahead and zoom out just to make sure. So I'm going to go ahead and zoom out here a little bit. And it doesn't look like they're going to cross anymore. I can zoom out one more time just to make sure. Nah, it doesn't look like they are. So I'm going to go back to my zoom standard. And what I'm trying to do is I'm trying to find the x value of where these two things intersect, and I can do that by using the calculate function. It's right above the trace button. So in order to use that, I hit second trace, and the intersect is the number 5. So I'm going to hit 5, and it says the first curve. So I'm going to say yes, that's my first curve. Hit enter. Second curve. Yep, that's my second curve. Hit enter. They ask me if I want to guess. No, I don't really want to guess. And the intersection point is 0.9988764. It says round to 2 decimal places. 0.998 rounds up to 1. So that would just be my answer. My answer would be 1.00 because 0.998 rounds up to 1.00 because that rounds up. All right, and that's it. That would be my answer right here. If you have any questions, please let me know, and I hope you all have a great rest of your week. Thank you so much.